calculated load of 209 to 191 amps exceeds the capacity of a typical 200 amp residential service, the backup generator with a 20 kilowatt rating is oversized for the calculated load. The homeowner has indicated a change in appliance plans, which could increase the load further. According to the National Electrical Code, or NEC, Article 225, the service entrance capacity must be sufficient to supply the maximum demand of all the loads in the dwelling unit. The maximum load of an individual dwelling unit is typically not to exceed 200 amps. Exceptions may be made for special equipment or loads. As the electrician, you have a responsibility to ensure the safety of the electrical system. Installing a system that exceeds the service capacity poses a fire hazard. You should verify the nameplate data by requesting the actual nameplate ratings of the appliances, including the range generator and any other equipment that could affect the electrical load. Use the verified nameplate data to recalculate the electrical load. Explore options for reducing the electrical load, such as using energy-efficient appliances or installing solar panels. If the recalculated load exceeds 200 amps, it may be necessary to upgrade the electrical service to a higher capacity, such as 400 amps. If the load cannot be reduced or the service cannot be upgraded, you may ethically refuse to install the system due to safety concerns. If the homeowner insists on installing the system, consider the following conditions. Firstly, obtain written documentation from the homeowner acknowledging the potential risk. Secondly, install load-limiting devices or surge protection to minimize the risk of overloading. And thirdly, inform the homeowner's insurance company of the oversized load and potential fire hazard. Installing an electrical system that exceeds the capacity of the service is unsafe and unethical. The decision of whether to install or refuse the system should be based on the verified load calculations, safety considerations, and the willingness of the homeowner to assume the risks. When performing load calculations, it is imperative to adhere to the standards set forth in the National Electrical Code, specifically Article 220, which provides comprehensive guidelines for calculating branch circuit, feeder, and service loads. Firstly, start by determining the general lighting load, which is calculated based on the square footage of the dwelling. Secondly, account for small appliance and laundry circuits, each requiring a minimum of 1500 volt amps. Thirdly, include the ratings of all fixed appliances such as dishwashers, water heaters, and cooking equipment. Fourthly, for heating and air conditioning systems, use the nameplate ratings to determine the largest motor load, and then add 25% of the next largest motor load. Fifthly, consider the demand factors specified in the NEC for various types of loads, which allow for reductions in the calculated load based on the likelihood of simultaneous operation. For example, Table 220.42 allows for a demand factor of 75% for dwelling units with 4 or more separately controlled electric space heating units. Sixthly, once all individual loads have been calculated, sum them together to determine the total calculated load. This value is then used to determine the appropriate size of the service entrance conductors and overcurrent protection. If the calculated load exceeds 200 amps, it is generally recommended to upgrade the service to a higher capacity, such as 400 amps. It is important to note that the NEC provides specific requirements for the installation of 400 amp services, including the use of appropriately sized conductors, overcurrent protection, and grounding electrodes. Additionally, local codes and regulations may impose additional requirements that must be followed. Failure to comply with the NEC and local codes can result in safety hazards, property damage, and legal liabilities. Therefore, it is essential to consult with a qualified electrician and obtain all necessary permits before undertaking any electrical work. When evaluating the electrical load for a residential dwelling, several key factors must be taken into account to ensure safety and compliance with the National Electrical Code, or NEC. Firstly, the general lighting load is determined by the square footage of the dwelling, with a minimum allowance specified per square foot. Secondly, small appliance circuits, which serve kitchen and dining areas, must be calculated at a minimum of 1500 volt amps each. Thirdly, laundry circuits also require a minimum of 1500 volt amps. Fourthly, individual appliance loads such as dishwashers, refrigerators, and cooking equipment are calculated based on their nameplate ratings. Fifthly, heating and air conditioning loads are determined by the nameplate ratings of the equipment, with special considerations for motor loads. Sixthly, it is crucial to account for any permanently connected appliances or equipment such as water heaters, dryers, and electric vehicle charging stations. Seventhly, the NEC allows for demand factors to be applied to certain loads such as lighting and appliances to account for the fact that not all loads will be operating simultaneously. Eighthly, once all individual loads have been calculated and demand factors applied, the total calculated load is determined by summing all the individual loads. Ninthly, this total calculated load is then used to determine the appropriate size of the service entrance conductors and overcurrent protection. Tenthly, if the calculated load exceeds 200 amps, it is generally recommended to upgrade the service to a higher capacity, such as 400 amps. 11thly, it is important to consult with a qualified electrician and obtain all necessary permits before undertaking any electrical work. The electrician should be able to perform a thorough load calculation and ensure that the electrical system is safe and compliant with all applicable codes and regulations. Ultimately, the goal is to provide a safe and reliable electrical system that meets the needs of the occupants while minimizing the risk of electrical hazard. In the context of electrical installations, several critical safety considerations must be addressed to protect individuals and property from potential hazards. Firstly, proper grounding is essential to provide a low impedance path for fault currents, thereby minimizing the risk of electric shock. Secondly, ground fault circuit interrupters, or GFCIs, should be installed in areas where water is present, such as bathrooms, kitchens, and outdoor locations, to detect and interrupt ground faults. Thirdly, arc fault circuit interrupters, or SIs, are designed to detect and interrupt arc faults, which are a common cause of electrical fires. Fourthly, overcurrent protection devices, such as circuit breakers and fuses, should be properly sized and installed to protect circuits from overloads and short circuits. Fifthly, wiring methods must comply with the National Electrical Code, or NEC, to ensure that conductors are properly insulated, protected, and supported. Sixthly, the electrical equipment and appliances should be listed by a recognized testing laboratory such as Underwriters Laboratories, or all, to ensure that they meet safety standards. Seventhly, regular inspections and maintenance should be performed to identify and correct any potential hazards. Eighthly, individuals should be trained on how to safely use electrical equipment and appliances. Ninthly, lockout/tagout procedures should be implemented to prevent accidental energization of equipment during maintenance or repair. Tenthly, emergency procedures should be in place to address electrical emergencies such as fires or shocks. 11thly, it is important to consult with a qualified electrician to ensure that all electrical work is performed safely and in compliance with applicable codes and regulations. By addressing these safety considerations, the risk of electrical hazards can be significantly reduced, thereby protecting individuals and property from harm. Evaluating the capacity of an electrical service involves several key steps to ensure that it can safely and reliably meet the demands of the connected loads. Firstly, gather information about the existing electrical service, including the size of the service entrance conductors, the rating of the main overcurrent protection device, and the type of grounding system. Secondly, identify all the loads that will be connected to the electrical service, including lighting, appliances, equipment, and any other electrical devices. Thirdly, determine the demand factors for each type of load, which are based on the likelihood that all the loads will be operating simultaneously. Fourthly, calculate the total calculated load by summing the individual loads after applying the appropriate demand factors. Fifthly, compare the total calculated load to the capacity of the existing electrical service to determine if it is adequate. Sixthly, if the total calculated load exceeds the capacity of the existing electrical service, consider options for reducing the load, such as using energy-efficient appliances or implementing load-shedding strategies. Seventhly, if the load cannot be reduced, consider upgrading the electrical service to a higher capacity. Eighthly, consult with a qualified electrician to ensure that any electrical work is performed safely and in compliance with applicable codes and regulations. Ninthly, obtain all necessary permits before undertaking any electrical work. Tenthly, document all calculations and decisions for future reference. 11thly, regularly monitor the electrical service to ensure that it is operating within its capacity. By following these steps, you can accurately evaluate the capacity of an electrical service and ensure that it can safely and reliably meet the demands of the connected loads. When assessing the ethical implications of an electrical installation, several key considerations must be taken into account to ensure that the work is performed in a responsible and trustworthy manner. Firstly, prioritize safety above all else, ensuring that the installation is performed in compliance with all applicable codes and regulations to minimize the risk of electrical hazards. Secondly, be honest and transparent with the client about the scope of work, the materials used, and the associated costs, avoiding any deceptive or misleading practices. Thirdly, respect the client's autonomy by providing them with all the information they need to make informed decisions about the installation, including potential risks and benefits. Fourthly, maintain confidentiality by protecting the client's personal and business information, avoiding any unauthorized disclosure. Fifthly, avoid conflicts of interest by disclosing any relationships or affiliations that could compromise your objectivity or impartiality. Sixthly, act with integrity by upholding professional standards of conduct, such as avoiding bribery, kickbacks, or other forms of corruption. Seventhly, be accountable for your actions by taking responsibility for any errors or omissions and promptly addressing any complaints or concerns. Eighthly, continuously improve your knowledge and skills by staying up to date on the latest codes, regulations, and technologies. Ninthly, promote sustainability by using energy-efficient materials and practices to minimize the environmental impact of the installation. Tenthly, treat all stakeholders with respect and fairness, including clients, colleagues, suppliers, and the community. 11thly, consult with a qualified electrician or ethics expert if you are unsure about the ethical implications of a particular situation. By adhering to these ethical considerations, you can ensure that the electrical installation is performed in a manner that is both safe and responsible. Calculating the electrical load for a residential dwelling involves several steps to determine the total demand on the electrical system. Firstly, calculate the general lighting load based on the square footage of the dwelling, using the values specified in the National Electrical Code, or NEC. Secondly, add the small appliance circuit load, which is typically calculated at 1500 volt amps for each small appliance circuit. Thirdly, include the laundry circuit load, which is also calculated at 1500 volt amps. Fourthly, calculate the individual appliance loads based on their nameplate ratings, including dishwashers, refrigerators, and cooking equipment. Fifthly, determine the heating and air conditioning loads, using the nameplate ratings of the equipment and applying any applicable demand factors. Sixthly, account for any other loads, such as electric vehicle charging stations, swimming pool equipment, or permanently connected appliances. Seventhly, apply demand factors to the various loads as allowed by the NEC to account for the fact that not all loads will be operating simultaneously. Eighthly, sum all the individual loads after applying demand factors to determine the total calculated load. Ninthly, compare the total calculated load to the capacity of the electrical service to determine if it is adequate. Tenthly, if the total calculated load exceeds the capacity of the electrical service, consider options for reducing the load or upgrading the service. 11thly, consult with a qualified electrician to ensure that the load calculation is accurate and that the electrical system is safe and compliant with all applicable codes and regulations. By following these steps, you can accurately calculate the electrical load for a residential dwelling and ensure that the electrical system is properly sized to meet the demands of the occupants. When evaluating the need for a service upgrade, several factors must be considered to determine if the existing electrical service is adequate for the current and future needs of the building. Firstly, assess the current electrical load by performing a load calculation as described previously. Secondly, consider any planned additions or renovations that will increase the electrical load, such as adding new appliances, equipment, or living space. Thirdly, evaluate the age and condition of the existing electrical service, including the service entrance conductors, overcurrent protection devices, and grounding system. Fourthly, check for any signs of overloading, such as flickering lights, tripping circuit breakers, or warm electrical panels. Fifthly, determine if the existing electrical service meets the requirements of the National Electrical Code, or NEC, and any applicable local codes and regulations. Sixthly, consider the potential for future load growth, such as the addition of electric vehicle charging stations or other energy-intensive equipment. Seventhly, obtain estimates from qualified electricians for the cost of upgrading the electrical service. Eighthly, weigh the costs and benefits of upgrading the electrical service, considering the potential for increased safety, reliability, and capacity. Ninthly, consult with the building owner or manager to make a decision about whether to upgrade the electrical service. Tenthly, obtain all necessary permits before undertaking any electrical work. 11thly, ensure that the service upgrade is performed by a qualified electrician in compliance with all applicable codes and regulations. By carefully evaluating these factors, you can make an informed decision about whether to upgrade the electrical service and ensure that the building has an adequate and safe electrical system. Refusing an electrical installation can be a difficult decision, but it is sometimes necessary to protect yourself, your client, and the public from potential hazards. Firstly, if the electrical installation is not in compliance with the National Electrical Code, or NEC, or any applicable local codes and regulations, you should refuse to perform the work until the issues are resolved. Secondly, if the electrical installation is unsafe or poses a risk of fire, electric shock, or other hazards, you should refuse to perform the work until the hazards are mitigated. Thirdly, if the client is unwilling to address safety concerns or refuses to obtain necessary permits, you should refuse to perform the work. Fourthly, if you are not qualified or experienced to perform the electrical installation, you should refuse to perform the work and refer the client to a qualified electrician. Fifthly, if you have a conflict of interest that could compromise your objectivity or impartiality, you should refuse to perform the work. Sixthly, if the client is asking you to perform work that is unethical or illegal, you should refuse to perform the work. Seventhly, if you have concerns about the client's ability to pay for the work, you should discuss these concerns with the client before starting the work. Eighthly, if you are uncomfortable with the working conditions or the client's behavior, you have the right to refuse to perform the work. Ninthly, document all reasons for refusing the electrical installation in writing and provide a copy to the client. Tenthly, consult with a qualified electrician or legal professional if you are unsure about whether to refuse an electrical installation. 11thly, remember that your safety and the safety of others should always be your top priority. By following these guidelines, you can make a responsible and ethical decision about whether to refuse an electrical installation. When considering conditional installation, certain factors come into play to ensure safety and compliance while accommodating specific client needs or circumstances. Firstly, assess the potential risks associated with the installation, such as overloading circuits, exceeding service capacity, or violating code requirements. Secondly, develop a detailed plan that outlines the scope of work, materials to be used, and safety precautions to be taken. Thirdly, obtain written consent from the client acknowledging the potential risks and agreeing to the conditional installation. Fourthly, implement load-limiting devices or surge protection to mitigate the risk of overloading circuits or equipment. Fifthly, install monitoring devices to track electrical usage and identify any potential problems. Sixthly, provide clear and concise instructions to the client on how to operate and maintain the electrical system safely. Seventhly, schedule regular inspections to ensure that the electrical system is functioning properly and that no hazards have developed. Eighthly, document all aspects of the conditional installation, including the plan, consent form, materials used, safety precautions taken, and inspection reports. Ninthly, consult with a qualified electrician or engineer to review the plan and provide guidance on best practices. Tenthly, obtain all necessary permits and approvals from local authorities before proceeding with the installation. 11thly, ensure that the conditional installation complies with all applicable codes and regulations. By carefully considering these factors, you can perform a conditional installation that is both safe and compliant while meeting the specific needs of the client.